In this video, I'm going to do problem number 5 from section 5.4 in the book. And that problem is to find the arc length of the curve y equals x to the 2/3 power from x equals 1 to x equals 8. So I've drawn the curve y equals x to the 2/3 power right here. And our points are 1, 1 and 8, 4. Well, how do I know it's 8, 4? Well, if you plug in 8 for x, then to find 8 to the 2/3 power, you'd take the cube root of 8 first, which would be 2, and then you square it, which is 4. So if x is 8, y is 4. And of course 1 to any power is going to be 1. So when x is 1, y is also 1. All right, now let's remember our arc length formula that we learned in class. That formula says that the arc length is the integral from a to b of the square root of 1 plus f prime of x squared dx. All right, for this particular problem, I'm using y instead of f of x, but f of x would be x to the 2/3 power. So let's start plugging some numbers in. We have the integral from 1 to 8, because we're going between x equals 1 and x equals 8, of 1 plus, well, the derivative of x to the 2/3 power would be 2/3 x to the minus 1/3. All right, and we still square it. 2/3 x to the minus 1/3. Why minus 1/3? Well, if you take 2/3 and you subtract 1, that would be like 2/3 minus 3/3. You get negative 1/3. Okay, now let's square the term underneath the square root here. If we square 2/3, we get 4/9. And if we square x to the negative 1/3, we get x to the negative 2/3. Right, we multiply negative 1/3 times 2, we get x to the negative 2/3. Okay, now here we have an integral that it's not quite so obvious how to evaluate this integral. Okay, it's almost a little mysterious. Should we do a u substitution? Should we let u be this in here? Well, if we did that, then du would be something involving x's, and we just don't have that out here or out here. So I think you have to be a little clever here. One way to do this is to rewrite the second term here as 1 plus 4 over 9x to the positive 2/3 power dx. Okay, if you have x to the negative 2/3, that's like 1 over x to the positive 2/3, and we still have this 9 on the bottom as well. Okay, now let's rewrite this. When we add 1 plus that fraction, in order to add two fractions, we need to have a common denominator. So let's make that common denominator be 9x to the 2/3 power. Okay, now the first term here, 1 is what over 9x to the 2/3? Well, it's 9x to the 2/3 over 9x to the 2/3. And here we'd have plus 4. Okay, so do you notice that this is equal to this, right? 9x to the 2/3 over 9x to the 2/3, that's just 1. And 4 over 9x to the 2/3, that's this. Okay, now if you take the square root of a fraction, right, the square root of a over b, that's the same thing as doing the square root of a over the square root of b. So what we have here is the integral from 1 to 8 of the square root of 9x to the 2/3 power plus 4 over the square root of the denominator. Now what is the square root of the denominator? The square root of this will be 9x to the 1/3 power. I'm sorry, 3x to the 1/3 power will be the square root of 9x to the 2/3. Okay, now notice at this point, actually we can do a u substitution, because if we let u be the part that's underneath the square root symbol, then du is going to be, I guess it would be 18/3 x to the minus 1/3. And do we have an x to the minus 1/3 out here? Yeah, actually we do, because we have an x to the positive 1/3 in the denominator. So here is where we're going to do a u substitution. We'll let u be 9x to the 2/3 plus 4, and du will be 9 times 2/3 x to the minus 1/3. Of course, the derivative of 4 is 0, dx. Okay, now another way of writing this is that du is equal to, that would be 18 over 3, which is 6, times 1 over x to the 1/3 dx. Okay, now do we have a 6 times 1 over x to the 1/3 dx? Well, we don't have the 6 here. We have a 3 in the bottom, but we do have the x to the 1/3 in the denominator. So how do I turn this into a 6 out here? Well, if I made this be an 18 right here, 18 over 3 is 6. So I've made the 6 that I want. Now obviously I can't just write in the 18 or else you're changing the problem, but if you wrote an 18 times 1/18th, then that would just be 1. And what I'm going to do with the 1/18th is pull it out front. Okay, so let's leave this sort of to the side over here. So what we have is 1/18th times the integral from 1 to 8 of all this right here. Now this 18 over 3, that's really 6, and we have this x to the 1/3. So actually this whole expression right here, remember, that's our du. So if we get rid of this whole thing here, that becomes du. So I'm going to put du instead of that. And what we have underneath the square root is just u. This 9x to the 2/3 plus 4, notice what that is. That's just u over here. Okay, now the 1 and 8, I could leave it as x equals 1 to x equals 8, but if I want to just stick with the u's and not go back to x's, I should change those from x values to u values. Okay, you don't have to do that, but I kind of prefer doing it that way. So if x is 1, what would u be? And if x is 8, what would u be? Well, look at this expression here. If x is 1, what is this? Well, 9 times 1 to the 2/3 is just 9, plus 4 is 13. So u is 13 when x is 1. Okay, now when x is 8, what is u? Well, if we take 8 to the 2/3 power, that would be 4. All right, take the cube root, which is 2, and then square it. It gives you 4. 4 times 9 is 36, and 36 plus 4 is 40. Okay, so what we want to do is integrate from 13 to 40 the square root of u. And remember, the square root of u is u to the 1/2 power. And the integral of u to the 1/2 power would be u to the 3/2 power, right? 1/2 plus 1, or 1/2 plus 1 is 3/2, right? Because it's 1/2 plus 2/2. Now over 3/2, but over 3/2 is the same thing as multiplying by 2/3. Okay, and then we can go from 13 to 40. Okay, now I like to just take this constant here, you can take it out front, and I like to just multiply 1/18 times 2/3. Now the 2 and the 18 can become a 1 and a 9, and we still have the 3 in the denominator, so this is really 1/27 times u to the 3/2 evaluated from 13 to 40. Okay, so if we just plug this in, now we don't have to go back to x's. We don't have to go back and plug in what u was in terms of x, because we changed these values to 13 and 40. If we hadn't done that, if we'd kept them 1 and 8, we'd have to go back to the x's. Okay, so what we have is 40 to the 3/2 minus 13 to the 3/2, and don't forget to put the parentheses here, and that's the correct answer. Okay, now the back of the book, okay, the book answer actually looks like this. It says it's 1/27 times, and let's see, how did they put this? I believe it was 80 times the square root of 10 minus 13 times the square root of 13. Okay, now that certainly looks a little bit different than what we have here, but I want to show you it's really the same thing. Now 40 to the 3/2 is the same thing as 40 times 40 to the 1/2. Okay, now why is that? Well, 40 to the 1 times 40 to the 1/2 would be 40 to the 1 plus 1/2, or 3/2. And 13 to the 3/2 also can be written as 13 to the 1 times 13 to the 1/2. Okay, and what we have here is 40 times the square root of 40 minus 13 times the square root of 13. And notice we're almost to where we need to be to getting it to look like the book answer. But the square root of 40 is the same thing as the square root of 4 times the square root of 10. And the square root of 4 is just 2. Okay, the reason they did that was because 4 is a perfect square, so we might as well sort of factor it out there. And what we end up with is 1/27 times, well, 40 times the square root of 4. The square root of 4 is 2. 2 times 40 is 80. So we have 80 times the square root of 10 minus 13 times the square root of 13. And that's exactly what the book answer is. Now, I'm certainly okay if you leave your answer like this. Okay, that's perfectly fine with me. But sometimes people want their answer to look like the book answer, and so that's how you would make it look like that book answer. By the way, I figured this out as a decimal, and let's see, what did I get when I plug this in my calculator? I got this is approximately equal to 7.634. Okay, so a length of 7.634. Now it's always a good idea to check to see if your answer looks reasonable. So let's go back up here. Does it look like 7.634 is reasonable? Yeah, well the distance, horizontal distance between these numbers is 7. The vertical distance between these numbers is 3. And so if you're looking at the straight line connecting these 2 points, the answer according to the Pythagorean theorem would be the square root of 49 plus 9, or the square root of 58. And you can check for yourself, the square root of 58 is a little bit less than the answer that we got. Okay, and we would expect it to be less because the straight line connecting these 2 points would be a little bit less than this curved line. You can check the square root of 58 is a little bit less than this number here.